Hi guys, happy Tuesday for my M1 and M4, happy Wednesday for my G1 and G4. This is your 5.3 notes. So what we're looking at today is we're kind of going off of what we had last class when we added our linear expressions. So if you remember, our linear expressions are the expressions that when we graph them, they create a line, right? Hence the word linear. Last class, when we added those, it was kind of similar to having to combine like terms, but before we could combine those like terms, we had to take everything out of the parentheses. And before we could do that, we had to make sure, one, that there was nothing we could do inside the parentheses before we took it out of there, and two, that there was nothing outside of the parentheses affecting anything inside of it. So today's going to be kind of similar, but instead of adding, we are going to subtract. So what we have to kind of do before we can do that is we have to remember when we learned about additive inverses. We talked about this a lot in the first chapter we did this year and a lot in the first semester. So if we recall, additive inverse is simply just a fancy word for the opposite, right? Remember we talked about that? So additive inverse is just a fancy word for the opposite. So like if I asked you what's the additive inverse of 7, you would say -7, right? That's kind of what we did with that beforehand. Now, when you have an expression, and so what I mean by that is like this, right? When you have your 5x minus 7, when you want the additive inverse of that, we can't just say, oh, it's like opposite, right? It's not as simple as if we just had a whole number, like the opposite of 7 is -7. It's not just as simple as that. Instead, what we're doing is we have to multiply by -1. So let's try that. We are going to find the additive inverse of 5x minus 7. So how we do that is we have our 5x minus 7. We're going to multiply that entire thing by -1. So we're going to do this, put our -1 up front. And now this should look a lot like one of our lesson 2 classes ago when we learned how to distribute. Because distribution is just multiplication to both things that are inside of our parentheses. So we're going to do that. -1 times the -5 and then -1 times our -7. So -1 times 5x becomes -5x. And then we distribute still, so we have to multiply the second term in our parentheses. -1 times that -7. Negative times the negative is always a positive, becomes +7. And that is your additive inverse. Okay, it's just the opposite. In order to find the opposite, all we're doing is we're multiplying by -1. So again, going back to when we learned this originally, the additive inverse of 7 is -7. Well, what's 7 times -1? -7, right? It's the same thing as what we've done. We're just now applying it to 2 different terms, okay? But we can do that because you just distribute this -1 to both things. Let's try the next one. Let's see here. I think there's 4 of them. We'll do one more together and then you can try them. All right, so remember we're doing additive inverse, so we're just multiplying the whole thing by -1. So we have our -7x plus 3, and we're going to multiply that bad boy by -1. When we do that, we do -1 times -7x, which becomes positive 7x, right? Because a negative times a negative is always a positive. Right there. And then we do the second term, -1 times +3 becomes -3, and we get our additive inverse of 7x minus 3. All right, I want you to go ahead and try 3 and 4, okay? So go ahead and pause me, and when you're done, you can check your answers. All right, pause. Okay, you've probably unpaused me by now. I hope you have at least. Let's go ahead and look at this. We did -1 times our 4x plus 8, which when we did that gave us -4x minus 8, because -1 times 4x is -4x. -1 times 8 is -8. And that's our answer. And then for number 4, we did -1 times -3x minus 6. We distributed the -1, and that gave us 3x plus 6, which is your answer. The biggest mistake that I see people make on this one is they forget a negative like this, right? It's so easy to go, oh, I'm just going to multiply it really quick. That's 3x plus 6, right? We can't forget this, right? Because if I didn't have this negative here, I would have the wrong answer, right? So you got to pay attention to those negatives. All right. I hope that makes sense. Here's what we're going to do. We're going to move on to our next example, and I want to say it's our last example. Yeah, similar here. All right, so This is what connects the most to our last lesson when we added those linear expressions. All we're doing today is we're going to subtract those linear expressions. And you might remember from last class that when I told you there'd be something different that would happen when we had this subtraction sign here, okay? So let's try it. Remember, we want to simplify this. That's the whole point of this whole chapter, is we are simplifying. So, looking at this, I'm going to bring this down, or I'm going to, actually before I bring it down, let's look. Looking at our 6x plus 5, we need to get this out of the parentheses. Is there anything happening in here that we can combine? There's not. Is there anything out front that is affecting it? There's also not. And so because there's not, we can rewrite this first set of parentheses, our 6x plus 5, because there's nothing that has to happen to it. That's the fun part, or the easy part. Although I don't like the word easy, we know that. It's the simpler part. Now we get to the second part, and we want to do the same thing. Now, when we added last week, we looked at it and we realized there's nothing that could happen. But now when we look at it, that's a little different. Is there anything we can do within these parentheses? No, they're still not like terms that we can't combine them. But what's in front of it? There's that negative sign, and if we recall, there's an invisible number right here. What invisible number is there? And I hope in your head you're hearing the word 1, because there is an invisible 1 right there. Right? It's hiding out there. Now this is where the additive inverse becomes helpful here, because if I have a negative 1 here, if I distribute that negative 1, is that going to change the inside of this? It is. So what we have to do is we now have to take that negative 1 and we have to simplify it. Ooh, I didn't know I could do that. We have to take that negative 1 and we have to distribute it. So negative 1 times our 3x gives us negative 3x. And negative 1 times the negative 2 gives us a positive 2. And now we've broken everything out of our parentheses, which means we can go ahead and we can combine like terms. So let's do that. We've got, let's see, 6x minus 3x, which gives us 3x. And then we've got 5 plus 2, which gives us 7. So our answer here is 3x plus 7. Alright, so it's very similar to what we did last class. The only thing that's different is that instead of adding these two linear expressions, we're subtracting, and that means that there is something affecting the second set of parentheses. Let's try it again. Let's see here. Come down to number 6. Alright, let's try it. So, we look at this. Is there anything affecting anything in these parentheses that I need to deal with? There's not. Is there anything out front that's affecting it? There's also not. So we rewrite that part. We can take our negative 3x plus 9 out of those parentheses. We're done with the first part for now. And then, this is where the fun part comes in. There's an invisible 1 hiding out right there. So what do we have to do with that? We have to distribute that bad boy. So let's go ahead and do that. We do negative 1. That's not a good choice. Let's do the blue. Negative 1 times 8x, which negative times a positive is a negative. So this becomes negative 8x. Negative 1 times negative 7. Negative times a negative is always positive. So this becomes plus 7. But we're not quite done yet. We are missing one step. We have to combine our like terms. So I look at my x's. Negative 3x minus 8x gives us negative 11x. And then 9 plus 7 gives us 16. So I'm going to add that on here. And that is our answer. Okay? That's kind of the gist of what we're doing here. Let's see how many more are there. There's 3 more. Let's do one more together. And then we will move on with our lives. Here we go. Hold on. My video got really small. I don't know what happened. Oh, now it's really big. That's okay. We'll be fine. Alright, let's try 7 and then I'll have you guys try them on your own. So, first off, 5y minus 2. Nothing I combine. Nothing I can combine. Nothing out front affecting it. So I'm going to just bring that down. 5y minus 2. And then I look at this part. There's nothing to combine here within our parentheses, so we're good. But, ding, 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 there's something here that we have to deal with. So what's invisible right there? There's that invisible 1 again. So now we have to distribute. Negative 1 times 7y becomes negative 7y. And negative 1 times 3 becomes minus 3. We're almost done. We just now have to combine like terms. 5y minus 7y gives us negative 2y. And then negative 2 minus 3 is negative 5. Can no longer combine anything else. So that's our answer. And then we're good. So I want you to go ahead, I want you to try 8 and 9, and when you're done, go ahead and unpause, and then we can check your answers. So reminder, you're doing both 8 and 9, okay? Pause me, come on back when you're done. Here we go. All right, you've hopefully unpaused me now. We can try this. So we have our 6z plus 5. There's nothing we can combine. There's nothing affecting it. So that is 6z plus 5. And then we have minus 9z minus 4. Well, there's nothing to combine on the inside, so we're good. But there is this invisible 1 here that we have to deal with. So negative 1 times the negative 9z, or negative 1 times 9z becomes negative 9z. Negative 1 times negative 4 becomes plus 4. We combine those like terms. 6z minus 9z becomes negative 3z. And then 5 plus 4 becomes 9, which is our answer. All right, that was 8. Last one, number 9, gives us 8x minus 2. Nothing we need to combine, nothing affecting it. So I've got 8x minus 2. And then we have our negative 1 here, so we distribute that. Negative 1 times 3x becomes negative 3x. Negative 1 times 1 becomes minus 1. We combine like terms. We get 8x minus 3x is 5x. And negative 2 minus 1 is negative 3, which is now our fully simplified expression. And that's our answer. So, last but not least, I want us to think really quickly about this. How does rewriting an expression using the additive inverse helpful when subtracting linear expressions? Pause me and write an answer. Okay? Pause me. Awesome. Okay, I hoped you paused me. If not, oh well, let's make sure you get an answer down. But when it says this, think about it. When we found the additive inverse, all we're doing is multiplying by negative 1. So when we do these problems, all we're doing here is we're multiplying by negative 1, right? So when you subtract a linear expression, it's kind of the same thing as you're just adding the additive inverse, right? Now, whatever way makes more sense to you to keep in your brain, totally fine with it. But I want you to answer that in some shape or form. And that's it. Okay, that's it. You did it. You did lesson 5.3. Your homework's on reveal. Do your best. You got this. We will go over everything when you get back if you have any questions. You guys are awesome. I love you so much. Have a great day.